Now, here what did you have? You have a triangle. And for a triangle, as I told you, we have 4 types of congruent lines. We talk about the first one, which is the perpendicular bisector. Now, let's talk about the second one, which is the angle bisector. The angle bisector means like there's a lines that cut each angle at 2 equal angles. So from its name, perpendicular, angle bisector, it bisects the angle. Angle bisector bisects the angle. Now, as you see now, they are congruent lines. They are many lines intersect at one point. So the point of congruency for the angle bisector, what we call it? We call it in center. So what we call it here? In center of triangle. So for the perpendicular bisectors with a point of congruency, we call it an circumcenter of a triangle. Circumcenter. Here, in center. For the angle bisector, we call it in center of triangle. Now, if we have a circle, and each circle, it has a center, and each circle, it needs a radius. Now, if this circle, or if the center of this circle located at the end center of the triangle, okay, I will say that this circle is inscribed in a triangle. Inscribed, and it's inside a triangle. The previous one, I told you it's circumscribed. Circumscribed, it's mean it is the circumcenter, or it's circumcenter the triangle. It's circumscribed above the triangle. It rotates above the triangle. So we call in the previous case, we said that the circle is circumcenter above the triangle. Here, no. Here, the radius is inside of the circle, is inside a triangle. Since the circle here, as you see, it is inside, and its radius, its center, is on the in center of triangle. Okay, so I will say that the circle is inscribed in triangle. Is it clear?
Yes, miss.
Yes, teacher.
So
Yes.
let's repeat them here in this video. So here we have a triangle. For the triangle, let's draw now the angle bisectors that cut the angle into 2 equal halves. What did they have? They have a point, which we call it the end center, our point I. If we draw now a radius from the circle, for the circle, and we draw a circle, where's the circle here? It's inside a triangle. So since it is inside, so I will say that the circle is inscribed in a triangle, and the point of congruency, we call it end center. Now, where is the end center is always located? Remember, the perpendicular, the circumcenter, I told you they are located, it could be located outside the triangle or inside. outside or inside. The end center, which is related to the angle bisector, is always located inside the triangle. So did you see how they are different? The perpendicular sides cut the line. The angle bisector cuts the angle. The points that all perpendicular sides intersected, we call it circumcenter of a triangle. And the point where the angle bisector intersected, we call it the end center. Now the points of the circumcenter of a triangle, it could be inside or outside the triangle. But for the end center, for the angle bisector, it must be inside a triangle. It cannot be here or here or here. It must be inside a triangle. Is this clear?
Yes.
Yes, teacher.
Okay. So the point of congruency of an angle bisectors of a triangle, we call it end center of the triangle. And the end center, it must be inside the triangle. And if we draw from the end center, we draw 3 lines that they are x, y, and z, or py, px, and bz. So here, the distance from, or the length from of py is equal to the length of px is equal to the length of pz. So that means they are, could be the radius of a center. So that means the center here of the circle here is inscribed in a triangle, as we see in the video. Now let's go to our theorem here. Our theorem 5.7 said like the bisectors of the angles of triangles. Here, if you draw now this triangle, let's draw it here. If we have this triangle, and for the triangle here, as we said, we have an angle bisector. The angle bisector means it cuts the angles into 2 equal halves. And when we cut it into 2 equal halves, we have a point, we call it point of congruency, or here we call it the end center of the congruent lines, of the triangle, sorry. Now the theorem says like, the bisectors of the angles are congruent at a point, which is the end center point. This point has an equidistance from the sides of the triangle. I mean, like, if I draw a lines, let's draw them like this. If I draw a lines from that point perpendicular on the angle and the side of the triangle, they will be equidistant. As you see here in this triangle, we have a triangle ABC, and we have a point P, which is the end center of a triangle. From this point P, if you draw a lines, okay, if you draw now a lines from point P, cut the triangle, and another line, cut the triangle, and another line, cut the triangle. They told me that these 3 lines, you draw it, have the same length. Means like the length of BY will be the same length of BZ and the same length of PX. This is here our theorem. So for the angle bisectors that cut or it's intersect in a point, we call it point of, or we call it end center of a triangle. For the end center here, what did they have? They have an a point, we call it point B. If you draw a line from point B, cut the triangles at point Y, X, and Z, so the length of these three sides will be the same. Is it clear?
Yes, miss.
Yes, teacher.
Okay.
And teacher, for the perpendicular bisectors theorem, the same.
Here
Side
for
will
the
be
angle
like-
bisector.
Okay. So, miss, what's the difference between these two theorems, theorem 5, 6, and this one?
Theorem 5, 6 said like, just a minute. This is the first. Well, I don't write it here, I think. Theorem 6 says that the perpendicular bisectors of the sides of triangle are congruent at a point equidistant from the vertices. It means here, like, if you draw, they are different. The first one, perpendicular bisectors, it means they are drawing from here. They are at there, or they are perpendicular to the sides. So that's mean we call it perpendicular bisector. Now for the perpendicular bisector here, the length of this part is equal to the length of this part and equal to the length of this part. So the congruent lines is the same as the lines that they are equal in length. But for the second one, we have the triangle. We have an angle bisector. So angle bisector, it's cut it from the angle. And then at this point here, the previous one, I told you that these are equal if they are perpendicular bisector. But here's no. Here's I know to draw another lines that they are perpendicular. Sorry here. Let's repeat it. So I need now to draw a lines, okay, that they are perpendicular on each side, and the lines that are perpendicular will have the same length. So for the angle bisectors, I need to draw a new angle, a new sides in order to say that they are equal in distance. But for the previous one, for the perpendicular bisectors, the lines itself is perpendicular, have the same length.
Yes, miss. Now I differentiate between the two theorems.
Okay.
Thank you.
Now the period is finished. Thank you so much. Tomorrow, inshallah, we are going to continue the angle bisectors, solve some examples related to them, and then start with this number 4.
Okay, thank you, teacher. Have a nice
Okay,
day.
miss.
Okay, thank you, teacher. Bye.
Bye.
Have a nice day, miss. Bye.
Bye.
Have a nice day. Bye.
Have a nice day, teacher. Bye.